Okay, I'm going to pick up right where we left off. So we know that one of these diagonals is 4 square root of 2, and that we have 2 of those diagonals. So we're going to have 2 times 4 times the square root of 2. Whew, that's a lot of stuff to say. Now we need to do the big diagonal. So this big diagonal on this other piece of the set. So for that one, we're going to use the same Pythagorean theorem. So we get 7 squared plus 7 squared equals, and I'm going to call that one b squared. So 49 plus 49. So we get 98 equals b squared. And we have to take the square root of that again. So I'm going to do, we're going to have to run, hold on. Hopefully this will be enough room here. So 98 is 49 times 2, and there's our 7 and 7. So we're going to pull out a pair of 7s and leave it at the square root of 2. And again, we have 2 of those diagonals. So 4 times 7 root 2. So I'm going to give you guys, you can pause, write down everything I just wrote, and then I'm going to finish the algebra. So 3 times 4 is 12. 4 times 7 is, let's get rewrite 4 times 7 again. Instead, we're going to make that 28. And then this becomes 8 root 2 and 14 root 2. When we simplify this again, we're going to get 40 plus 22 root 2. Now this we actually are going to have to put into our calculator and get a number out of it. When we get that number out, these two things added together give us approximately 71.1. So that means it's going to take 71.1 feet of board to go around this box, around the big box, and through all 4 of those diagonals. Now it asked us, I'm going to write that 71.1 right here so we don't forget about it. It asked us if 75 feet of wood would be enough. Well, 75 feet of wood is bigger than 71 feet of wood. So it is, in fact, enough. Okay, we're going to go on to 5A now. So 5A says we're going to use our rules to multiply and get the reduced form of these products, okay? So if I remember my rules, I'm just going to distribute this. So I'm going to get 2 cube root of 7, which we know what that is. It's just 2 cube root of 7. And then here, both of these are cube roots. So I am just going to multiply what's inside. So 49 and 7. Then if I break apart my set, my 49, I get 7 times 7 times 7, which means I have 3 7s. If I have 3 of something, can rewrite it like that. And then you smarty pants people know that the cube root of something cubed is just that number. So this is our reduced radical form. Now 5B might give you a little bit of pause. You look at that and you're like, I have no idea how I'm going to do this. Well, guess what, peanuts? These are 2 binomials. And we know when we have a binomial times a binomial, we are going to FOIL. And actually, because you're really, I'm gonna FOIL this, but you could also use the property that you learned in topic 3 when you have the same thing. You'll notice that this is 2x minus root 3 squared. And with that, this is your A term, this is your B term, so this would be 4x squared minus 4 square root of 3x plus 3 without foiling. But if for those of you who need to see me FOIL it, I'm also going to FOIL it. So our first terms are 2x times 2x, which is 4x squared. Our outer terms is negative 2 square root 3 of x. our inner terms are also negative 2 root 3x. And our last term is the square root of 3 times the square root of 3, which is just 9. Now, these two terms are exactly the same. They have the same radical and the same variable. So we're just going to add those coefficients out front. Then two negative 2's, which become negative 4 square root of x, or square root of 3x for those two middle terms. So now to write my final, we'll have 4x squared minus 4 square root of 3x plus 9. And there is your reduced radical form when you're multiplying that out. Okay, example 6 I feel like is more of a review question because we talked about rationalizing denominators in topic 3. So when you're rationalizing a complex denominator, you use the conjugate. It's no different when you have a rational or an irrational denominator. So our conjugate is going to be 2 minus root 5. So we're going to have 1 over 2 plus root 5 times 2 minus root 5. I'm going to do that. 2 minus root 5 over 2 minus root 5. Remember that this is just like multiplying by 1, so it doesn't change anything. So our top is just 2 minus the square root of 5. And then our bottom, if you'll recall, is the square of the first, which is going to be 4, minus the square of the second. The square root of the square root of 5 squared is just 5. So that gives us 2 minus the square root of 5 over negative 1. Well, now we have that negative 1 down there. So what that does is we have 2 over negative 1 minus the square root of 5 over negative 1. And that makes that negative 2 plus the square root of 5. And there's our final answer. So we are now done with 5-2. You have an extra half sheet, which includes your properties of radicals. So that's everything that we've done today on all of our notes. And you can kind of review back through that. As always, if you have any questions, I will be happy to answer them in class. And for now, I am going to stop sharing.